Okay, today's lecture, this is naming nomenclature on acids. And with this one, we start off the first element is hydrogen. That is our clue that we have an acid. So, inorganic acids always begin with the hydrogen ion. It is a cation. It is acting like a metal. Because since all have the same cation, they are named for the anion, the negative portion of the compound. The first thing you should probably do is identify the anion, the negative portion, and then change the name according to the ending of the anion name and add the word acid. So as a rule, I look at my compounds and I want to determine if it is one, binary, two elements, or if it has a, say, we call it, therefore uses polyatomics. Okay? Now remember, they all start with hydrogen. So the first element will always be H. So with a binary, this is the first rule. We take the anion, whatever it is, we're going to, and depending, and we're going to add it. Normally, if it was a solid, we would have "ide," like if I wanted to say HCl. If this was a solid, a powder. Remember, acids are in water. They can't be an acid unless it's in water. If I named this, this would be hydrogen monochloride as a salt. Once I put it into water, it becomes an acid. Now, normally they are purchased as a liquid. Therefore, I need to name this as an acid. So the first thing I see that I have two elements, and based on this "ide" from the chlorine, I need to use the prefix hydro. And I'm going to add it to the stem of the second element. And we could say we have, in an element like compound like this, we have hydrogen and an element to follow. This tells me element to follow, clue. And this would be chloride. So I'm going to change the ending to "ic" and add the word acid. Anytime I see a H, I'm going to write the word acid. Then I'm going to look at the anion. Write it stem, ic, acid. These what I call the little guys. And they have big names. I can also, for example, I can write HBr. I see that it's two elements, therefore I'm going to write the word acid. I see that this is bromine. Because there's two elements, I use the prefix hydro. This would be hydrobromic acid. H2S, two elements. I write the word acid for the hydrogen. Two elements, I'm going to write the prefix hydro. Sulfur, sulfuric acid. Now, when I see that I have hydrogen and the second part is a poly, I have more than two elements. So I have a little mnemonic, ic, I8, a humongous bite. So what this means is if the polyatomic ends in 8, I change it to ick. If it ends in "ite," I change it to us. So I have two scenarios. I can say I have the stem. So if I had the stem plus 8, therefore I'm going to write the stem of the polyatomic, add the suffix ick, and put acid. For example, HNO3. I see there are 3 elements. I'm going to write the word acid. I'm going to look up NO3. NO3 is nitrate. I changed the ending to ick. This is NITRI, nitric acid. Move this up a little bit. So, stem, ick, acid, stem, us, acid are the 2 formats depending on the ending of my polyatomic. So, examples. H3PO4. So I see I have hydrogen, so I'm going to write acid. It's an acid. That's my clue. I'm looking for things with acids. PO4 is sulfate. So I'm going to use this stem, H, go to ick. This is phosphoric acid. He is not phosphic. They put an OR in there to make it sound better. I can also, this is one example, to H3PO3. When I look, I see the word acid for the H. I have a polyatomic. I look it up on my chart. When I look at PO3, I see this is phosphite. So phosphite go to us's, so this is phos for us acid. Another example. Okay, now there are some exceptions, of course. For example, HCN. I see that this has more than 2 elements. So I know it's an acid because it starts with the H, so I'm going to write the word acid. CN is cyanide. Because it ends in "ide," I am going to treat it as though this was an element, a single element, but it's not. Therefore, I'm going to write hydro, CYA, and change the ending to ick, hydrocyanic acid. H2O. Now, it's a water. This is H2O. This is water. Okay? It does not have a special name. It is an acid, but H2O was named before the system of naming compounds. If this would have been truly named as a acid, this would be hydroxyic acid. But we don't. We call it water. All right, let's work a few other examples. So it says name the acids. So the first thing I noticed, it starts with an H. That's my clue. It's an acid. Clue. Acid. So once I see that H, I'm going to write the word acid so I don't forget. So I see that it has more than 2 elements. I'm covering up the H. I'm going to look up CO3. And when I do that, I'm looking it up on a polyatomic chart. These are not individual elements. These are combined. And I see this is the first one in the second column, carbonate. Carbonate is changed to carbonic. So this is carbonic acid because it's a polyatomic. Going to your right, I see H. This is acid. I see that it's followed by an element, therefore I use hydro. This is bromine, change the ending to bromic. Acid. We have already named this guy. This is phosphorus acid. This came from phosphite. I's turn into us's. The H's because the acid comes because we have H's. They always have to start with an H. Now we went from compounds to, oh, one more, pardon me. We've already done this one. So this is hydrocyanic acid. I see that it starts with an H. That's the first question. I'm always looking at what is the first thing. They help me in what rules I use. So hydrogen is acting like a metal. This is my clue that it's an acid, so I'm going to write acid. Cover up the rest. I have BrO2. So when I look up BrO2, I'm just going to scan. So BrO2 is bromite. Bromite, since it ends in the ending "ite," I change it to us. This is BrOMOUS acid. Okay. Now, we have to be able to also go from chemical formulas for an acid to the actual chemical formula. And remember, acids start with H. And in this we also use, because these are ions, we use cross in the formation of these compounds. So I look for clues. I look for the clue hydro. I look for endings like ic, and us, these suffixes. They tell me what the endings were changed from. So that will help me in the formation of these compounds. So I see the word acid, so I'm going to write H. And I know hydrogen has a +1 charge. It always has a +1 charge. And I look at periodic. I do not see hydro. Therefore, I know this must be a polyatomic. So periodic, X go to 8. So this is periiodate. So I'm going to start looking for periiodate. Oh, right here it is, IO4 -1. So I'm going to write IO4 -1 crisscross. So this one goes here, this one goes out here. So final answer is HiO4. And I can go backwards like we did earlier. I can always check to see if I come up with the same name. So if I cover up this, I see, oh, I have hydrogen. Therefore, I'm going to write the word acid, and I'm going to cover up the H, and I'm going to look up IO4, and IO4 is periiodate. Change the ending to ic, periodic acid. Same name. I can check myself. I can go from one to the other. When I go to the right, I'm looking for clues. Oh, there's hydro. That means element to follow. Acid means I start with an H. So because hydro is telling me an element to follow, selenic must be an element, and it's found on the periodic table. So the closest thing that selenic would be selenium, Se. It is found in the group 16 under oxygen, which has a -2 charge. Crisscross, so my 2's going here and my 1's going here. Final answer is H2SE. Looking more for clues. Next one. I see acid, write H1 plus or +1. I don't see hydro, so this means this is not an element, must be a poly. And I see us, so this must be, instead of arsenous, it's changed to arsenite. So when I look to find arsenite, I see ASO3 -3. ASO3 -3, crisscross. This 3 comes here, this 1 comes outside. Because it's a 1, I kind of don't really need to do anything with this. So final answer is H3ASO3. Move this up a little bit. Can't get it to move well today. It's stuck. My fingers won't let it go. All right, next guy. All right, looking for clues. Looking for clues. I see the word acid, so I'm going to write H1 plus. I don't see hydro, so there's no element to follow. That means a polyatomic. It ends in ic. So ic goes to 8. So this is chromate. Looking on my polyatomic chart, I see that chromate is CrO4 -2. Crisscross. This 2 comes here. The 1 comes outside, telling me I only need 1 chromate. I need 2 hydrogens to 1 to make this compound equal 0. So final answer is H2CrO4. Moving to the right. I see H, I write hydrogen. I see acid, I write hydrogen. More clues. I see hydro, element to follow. So now look at fluoric, means it's fluorine. This is F, which has a -1 charge. Crisscross, HF. Final answer. This concludes our lessons on acids today. Thank you. Have a great day. I would like to review nomenclature as a whole. I would like to start out with that you have, if you are given a chemical formula, the first thing I want to ask is, what is the first element? This first element basically tells me what rules I use. If it is a non-metal, this is where I use prefixes like mono, di, tri, etc. I do not reduce. Okay? Or if the first element is a metal, Okay, the first element is a metal. I use criss cross. Okay, so I use the metal. I write the metal's name. I must know, does this element have one charge or more than one? Basically one charge. I know it. I know it.